Hello and welcome to my channel. Ivan is here, and in today's video I am going to implement interior mutability in Rust. And if you don't know how the references and pointers work in Rust, you have to watch this video. Yeah, I'm serious. It is a very detailed video about the references and pointers in Rust. Go there, watch that. So let's get started. And I'm going to take standard libraries cell and re-implement it in style of redo to learn with the name MyCell. I know, very creative, I know it. With the methods new and set. So you can create MyCell, set the value, and it will change the value. And I'm going to implement Deref for MyCell, just to easy get the values inside. That's it. Let's dive in. So, tests first. First of all, create MyCell. Then assert. It should be equal 10. Then let's change it. And assert again. This is the simple idea. We have cell, and cell is not mutable. But I'm changing that here. I'm setting the new value and verifying that cell as a 25. And it happens by the Deref thread. Let's run it. And of course it's failed. Let's implement our struct. And MyCell is the carrier of UnsafeCell. And let's implement MyUnsafeCell. So now we have two structs. The first of all, MyCell, it contains the UnsafeCell, and already here the MyUnsafeCell contains the value with this type. Then let's implement MyUnsafeCell. New, and then ptr method. It returns mutable pointer to value inside of MyUnsafeCell. Let's implement it. Notice self is not mutable. Turn mutable t. That's it. Then let's implement MyCell. And our second method, set. Notice not mutable self. And this is unsafe block. I forgot the value here. New value with the type D. And we have unsafe block here because you see this asterisk. This means we are dereferencing the pointer, and dereferencing the pointer all the time unsafe operation, because potentially it could point to some garbage data or anything else. So all the time it's dangerous. But now we're pretty sure that everything is fine, because my UnsafeCell take care about this data here, and it will never drop them before the MyCell will drop, because when MyCell will drop, then and my UnsafeCell will be dropped, and then the value t will be dropped. Let's check out our implementation of the tests. I definitely see the errors here, and to fix them I have to implement the reference, Deref. Of course, quick fix. You have to import Deref. Now it's done. And let's implement Deref for MyCell. And here explicitly calling Deref method from UnsafeCell. Now I still have an error in tests. Let's fix it. First of all, let's dereference cell and the reference here. Then we don't need to have a reference to the number, so remove references, save it, and run tests. And now everything works fine. Now our test passed. Very good news, right? Let's see closely an example. First of all, I created cell, then verify that cell contains 10. Then I changed the value inside of the cell by invoking this set method, setting the 25 and verifying that I have a 25 inside. And cell is not mutable here. And how it happens? First of all, let's navigate to set. We invoking this method on normal reference self, but we're asking, providing us the mutable pointer here. You can see I ask to provide me the mutable pointer of type t, and t is value inside of MyUnsafeCell. Then we reference this pointer and set a value there. Reference the pointer is unsafe operation, but here we are pretty safe because MyUnsafeCell cares about the value inside, and the Rust provide us the guarantee that it will be all the time here, so we will never get a null pointer in this case. And what happens with the old value? What happens here when you set a new value? The old value will be dropped. Let's prove it. I implemented a struct, my user, with a simple and single field inside, name with the type of string, and then I implemented drop from a user to verify that it's dropping with this name. Let's implement the second test. In the second test, I do the same thing. I first of all create cell with the first user with name John, then verify that John inside, then set a new value, and here, before this line, before this print, we have to see how the John is dropping, and then verify that new value inside of the cell. Let's run this test. Now you immediately see dropping John here, and then you see this line after cell. After set, I mean. After set. But it doesn't matter. So after set, we are dropping the Jan. It works. No memory leaks. And here I implemented a simple interior mutability pattern with MyCell struct and MyUnsafeCell of course. But if you want to use some more robust and tested and well-tested struct, so go and use cell from standard library, or use refcell also from standard library. They well tested, they have a lot of good implementations, they thread protected, and etc. So don't implement it by yourself. I'm doing that just for learning purposes, just to understand how it works internally. So don't forget to like and subscribe for more content like this, and I will see you in the next one.